Good morning, my YouTube viewers. Crystal here. I'm here this morning because I want to make you another video. I've had to turn my camera off because it's 4 o'clock in the morning and I'm not really presentable. But anyway, I found that it works out better if I make my videos in the middle of the night because I have more time to do other things during the day. So I wanted to make you another video on the diabetes website. I know I made you a video on the diabetes website yesterday, and I was intending to do a blog post, and I did actually copy all of the pictures into the blog post, but basically when I copied all the pictures into the blog post, I had some things I had to do, and because I had some things I had to do, I couldn't actually finish the blog post. And then so I decided I was going to go ahead and do my best to try to find out what was going on with this diabetes data set. And when I did that, I actually stumbled across the real diabetes data set, because the diabetes data set that I had been using had already been standardized. It hadn't been normalized, it had been standardized. And the documentation on sklearn tells you that the diabetes on this data set that they use, I'll see if I can find it. I know that you can't see it. It says each of these 10 feature variables have been centered and scaled by the standard deviation times n samples, i.e. the sum of squares of each column totals 1. So it had already been centered and mean centered and scaled. And because it had already been mean centered and scaled, I couldn't really do the analysis on it that I wanted to do. And whenever I tried to run up a chart, the chart didn't look very good, and I just wasn't happy with it. And as a result of that, I didn't get a chance to actually do a blog post yesterday. So because I didn't get a chance to do a blog post yesterday, that means that I lost money. And then so I went and found the actual data set. But the actual data set had problems as well, because the actual data set was in a text file. It wasn't in a CSV file. It was in a text file. And then I had some problems trying to figure out how to read the text file, and I had some other problems. So I had to decide that when I finally did get to read the text file, I decided I was going to convert it to CSV. So I don't know if converting it to CSV helped or not. But the text file itself, because I was having problems, wasn't really doing what I wanted it to do. So now it's been converted to CSV. And because I was doing all that stuff, that meant that I lost money because I didn't get to do a blog post yesterday. So I'm going to endeavor to do a blog post today, and I'm going to do the blog post today on the new diabetes data set, but I'm also going to do a second blog post on why I wouldn't use sklearn's diabetes data set. And then when I do that, I'm going to explain to people why I chose not to use sklearn's data set and why I'm using the original data set. So now that you know the background of why I'm doing a second video on the diabetes data set and why I didn't get to do a blog post yesterday, I will go ahead and do the code review for the new diabetes data set that I got. Now, what I did was, when I got a hold of this diabetes data set, basically what happened was on the sklearn website, they said that the source for the diabetes data set is this particular web address. So I clicked onto the web address, and then I got another website. And then whenever I clicked onto the other website, they had the link to the original data. And so basically I'm using the original data, but it wasn't a CSV file, it was a text file. So I had problems reading it because I'm still learning Python. And so that's why it took me a while to figure this out, because everything I do, because I'm still learning Python, so everything I do, I have to do because I have to try to figure out how to do something. And then whenever I figured out how to do something, then I can do it. So that's what this situation is. So we wrote the program on Google Colab. One problem that we have with Google Colab that I didn't know until a couple of days ago was that Google Colab does not always have the most current version of a library on it. And in this particular instance, it didn't have the most current version of AskFrame on it, which is what I wanted to use for the previous video. And because it didn't have AskFrame on it, I had to install the most current version and then get AskFrame. But even whenever I got the AskFrame, it still didn't work out the way I wanted it to work out. So we're going to go ahead and carry on with this presentation because we don't really need AskFrame anyway. But I just wanted to bring to your attention that although I use Google Colab, and Google Colab is a good program to use, it does have its limitations, i.e. it doesn't have the most current versions of the libraries installed on it. And I did actually send Google Colab feedback and ask them to install the most current version of the library. But as far as I know, they haven't done that. And then whenever I wrote my program on Google Colab, then what I did was I stored it on my GitHub repository. But what I intend to do is I intend to make a blog post. And then when I make the blog post, I will give you the link to the program. And at the moment, I'm storing this on the miscellaneous predictions because I don't have a data set of my own to use. I'm using a data set that I borrowed. So I just put it in miscellaneous predictions. But I think at one point, miscellaneous predictions will be full up. And when miscellaneous predictions is full up, then I'll probably have to open up another miscellaneous predictions repository to store my things in, because it's a bit difficult because you have to think, well, should I open up a new repository just for diabetes, or should I use miscellaneous predictions? Because I don't have a data set for the diabetes. I'm using a data set that I borrowed from somewhere, and as a result of that, I'm just storing it in the miscellaneous predictions. So it's always difficult for me to decide where I'm going to actually store a file, but this file is stored under miscellaneous predictions. You can see I've got you a link to the website right here. So if you click onto the website, then you'll go to that web page. And then when you go to that web page, then what will happen is you will get a link to the actual data set. But the data set is a text file. It's not a CSV file. And then after we created our program, then what we do is we go into import libraries. And we're just going to import the libraries that we're going to need to start with. So that's Pandas, NumPy, Matplotlib, and Seaborn. And then we're going to read the file. This is the file that I got off of that website. And then we had to do, in order to read the file, we had to do a delimiter equals /T, which means it's a tab. The delimiter is a tab. And when you do the delimiter is a tab, then you get your data set, which is what we want. That's what we want. And so you can see that this data set here looks so much better than the data set that I had on the video that I made yesterday, which is why after I make the blog post for this video, I'm going to turn around and say why I wouldn't use sklearn's diabetes library, and I'm going to say exactly why. I'm going to say it's because their data has been pre-scaled, and because the data has been pre-scaled, you can't really perform an analysis, which is what we wanted to do. We wanted to analyze the data, and not only can you not perform an analysis, one of the graphs that I tried to produce turned out really wonky, and I think that is because the data had been pre-scaled. And so I had some difficulties with the file. I don't know if it was because I messed up with the coding a bit, or if it was because it was a tab delimited file. But I just decided, because I was having problems, and I finally figured out the problem eventually, but because I was having problems, I decided that I was going to make it a CSV file. I was going to convert it to CSV. So in order for me to convert it to CSV, I said data.toCSV, diabetes.csv, index equals false, df equals pd read CSV, diabetes CSV, df. So now we've got a CSV file. I took that text data that had been delimited by a tab, and I converted it to a CSV file, which is what I'm used to working to. So I don't know if me converting it to a CSV file made it easier for me to work with, or if it was because I had something wrong with the coding. But we just converted it to a CSV file. It took only, not necessarily one line of code, but one cell of code. It only took me one cell of code to convert it to a CSV file, and I just feel a lot better with it in CSV format because it's what I'm used to working with anyway. And then so what we do is we do an info function so we can check. So you can check and see that there's like pretty much an equal mix between integers and floats, but all of them are numeric. And because they're all numeric, they're going to be easier to work with because they're all numeric and we don't have anything that we have to encode. So I checked on the columns. So these are the columns that are in this data set. So that's good. Then I checked on any null values, and in this instance, they're not any null values, so you don't have any information that you have to clean, any values that you have to impute, because all of the values are in there already. So that means I didn't have to do any imputation. And then what I did was I did a heat map. So you can see on the heat map that if you like heat maps, then you can determine how the independent variables fit in with the dependent variables. And if you're into heat maps and you like looking at that sort of thing, well, here's your heat map. So you can see for yourself how all of the different variables relate to each other. So now what we're doing is we're going to do the analytics. So what we've done is we've done a graph of y. So y is your target variable. And so you can see this is what tells you what the disease progression is. And we've done a scatter plot on age and how it relates to disease progression. We've done a scatter plot on BMI and how it relates to disease progression. We've done a scatter plot on blood pressure and how it relates to disease progression. So now what we've done is we've done a Vineland chart, and you can see how the violin chart relates. The most current age is around 50. I guess that's the most current age of the people that they tested. So the max age is 79. The min age is 19. The median age is 50. And you can see that the median age being 50 pretty much corresponds with the violin chart. You can see that the highest incidence of the age is 53. And the lowest incidence of the age is 74. So that's just how many ages of the people that they monitored. And now we're going to check on the sexes. You have sex 1 and sex 2, but unfortunately they don't say whether the sexes are males or females. So we don't know. We just know sex 1 and sex 2. And so unfortunately, but they didn't give us that information. They didn't say whether it was a male or a female. So you can see that sex 1 had 235 instances and sex 2 had 207 instances. So there are slightly more examples of people of sex 1. And then so the highest incidence of sex 1 was number 1, and the lowest incidence of sex 2 was number 2, which is pretty self-explanatory really, because there were only 2 sexes and only 2 numbers. Now what we're going to do is we're going to check the BMI. So we've done a violin chart, so you can check the BMI. The maximum BMI is 42.2, and the minimum BMI is 18. That's somebody who's really slim. And the median BMI is 25.7. And so you can see on the violin chart that the median BMI is around 25. And you look at the highest incidence of the BMI is 24.1, and the lowest incidence is 19.5. So you can see the BMIs there. Now we're going to look at the blood pressure. And so we've got a violin chart for the blood pressure. The maximum blood pressure is 133. And the minimum blood pressure is 62. And the median blood pressure is 93. I do know a little bit about blood pressure because I have to have my blood pressure tested. And so I think that they're referring to the lower number, because when you're checking someone's blood pressure, they have an upper number and a lower number. And the upper number is normally above 100, and the lower number is normally below 100. So 133 is not very good. That's not a very good number. And 93 is supposed to be around 80 or something like that. I'm not sure exactly what it's supposed to be, but 62 is pretty low. So I think what they're doing is they're going by the lower number. But again, they don't say they didn't say what sex the person was, and they're not saying what number of the blood pressure that they're using, so we can't be sure. So the highest incidence is 83, and the lowest incidence is 66. So I think it's the lower number that they're going by, just what I know about having my blood pressure tested, because they say that I have high blood pressure and I have to take medication for blood pressure, and I'm trying really hard to lose weight, but it's difficult. It's very difficult. So now what we've done after we have analyzed are a few of the independent variables, because I didn't want to analyze the variables of things that I don't really have any understanding of, because it's medical terminology. So I decided, well, because if I don't have any understanding of it, then the normal, ordinary person is not going to have any understanding of it either. So it's not going to mean a whole lot for me to analyze it. So I just analyzed the basic stuff that normal, ordinary people can relate to. Now what we've done is we've defined our x and our y values. So your y is your df.y.values, and your x is df dot drop, y axis equals 1. So this was a pretty good data set to form your x and y values in, because we didn't have to impute any values. They were all already in there. Number one, we didn't have to encode any values because we didn't have any object columns or categorical columns. So it was a very easy data set to formulate an x and y value on. So you can see your x, and then you can see your y. Now what we want to do is we want to normalize our x, and that's what happened in the previous data set. The previous data set wasn't normalized. The previous data set was scaled, and there's a difference between scaling and normalization, and that's why the test that I was doing on the previous diabetes data set didn't turn out the way that I wanted them to turn out. And normalized is pretty easy. You can look at the formula for normalized and you can see that it's pretty easy. What it does is it takes the values and it converts them to a value from 0 to 1. So the lowest value is going to be 0 and the highest value is going to be 1. And it's a pretty easy formula. And so if you know the formula to normalize data, then you can probably figure out how to unnormalize it, how to reverse the normalization, which I don't know how to do that at the moment. I would have to study up on my mathematics because I haven't studied mathematics in 40 years. So I'd have to refresh my mathematics, but basically what you would do is you're going to do the opposite of what you did on this. If you want to reverse the normalization, then you would go through and you would do the opposite of that. So that's one thing that I need to learn how to do. One thing that I need to work on is how to reverse normalize something that's been normalized. But I don't need to do that at the moment. So after we have normalized our data, then we're going to split the x for training and validation. And so we're going to use train test split on sklearn. And our test size is 10%. Then we check the shapes of our training and validation sets to make sure that they're okay. And then we define the model. And in this instance, I'm going to use linear regression. I know that there's other models that I could have used where I would have gotten a better rate, but I just decided to use linear regression. And I did actually experiment with like Lasso and Elastinet, and I didn't get a better reading. I got the best reading with linear regression. So I'm just going to keep it at linear regression. And so we've got a 53% accuracy, and then we predicted on the validation set, and we put it on a root mean squared to check the error, and we got 3319.731. That was the best error that I received of all of the models that I tested it on. So that was the best error. So I decided to go ahead and stick with linear regression, which will be good because if I'm sticking with linear regression, then it's going to be better for me because then I can do that other blog post of why I wouldn't use sklearn's version of the diabetes data set. But I got the same reading on this data set that I did on the diabetes data set. But the chart, I didn't get to do analysis, which I wanted to do. And the chart that I tried to make turned out to be really wonky. And because the chart that I tried to make turned out to be really wonky, then I just decided that it's best not to use that data set. We created a data frame so you can see, you can check the actual values against the predicted values. And you can see that doesn't look very well. And then what we have done is we plotted our predicted values against the actual values, and you can see that. So you can see that the predicted values of just kind of like trying to form a straight line. And then we plotted another chart, which is a little bit easier to see. And then if you looked at the chart that I had produced on the data set that I used with sklearns, the chart right here appeared to be really wonky. But this chart right here, you can see where there's lots of errors in it, that it's not perfect, but it does compare the actual values against the predicted values. So that's it. That concludes this code review for the diabetes original data set using linear regression. I'm sure I could have used another code like ADA boost regression, and I may have gotten a better outcome. And I may go back later and try to use ADA boost regression and see if it's improved. But just for this exercise, we're using linear regression, and maybe I'll try to improve the accuracy by using ADA boost regression. So this concludes my presentation. If you like my presentation, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap the bell button on the side of this subscribe button, and you will be notified every time I make a new video. If you like the work I do and you want to support me, then I've got my email address to my PayPal account if you want to make a donation, because I don't have enough subscribers, so I can't monetize. So any donations will be very gratefully received, because I put a lot of work into the code which I make the videos for, and if anybody wants to help me out, it would be just fantastic. If you don't have any money, then you can help me out by reading my blog post. So I intend on making 2 blog posts on this data set. One blog post is to go over the code review, which I've already done, and the second blog post is going to be why I wouldn't use the data set provided in sklearn. And so that's it. That concludes this presentation. So thank you so much for watching, and I look forward to making other videos for you